Hi guys, welcome to my YouTube channel. So in today's session, we're going to study about what is automata theory. So before starting with the session, let me ask you all a question. Can a computer solve every problem that we give it? And if not, how do we know which problem are possible for a computer to solve and which problems are not possible for a computer to solve? Okay, so that's when the automata theory comes into picture. So that's what we are going to study about today. What is automata theory and why it exists? Okay, so automata theory is also known as theory of computation. So computation means what? It is nothing but processing, and as we know, processing means what? Any task that can be performed by a computer is known as processing. Okay, so let us take an example where an engineer is told to solve a problem. Okay, so what the engineer is going to do? The engineer is going to generate an algorithm. That is going to be the first task. After generating the algorithm, he is going to write a program for the given problem. Okay, so this is what the engineer is going to do. Okay, he is going to write a program for the given problem. Okay, but to identify if the problem is computable or not computable by the computer. What I meant is whether the problem can be executed or it cannot be executed by the computer. So how do we know about it? Okay, so as I told you all earlier, can a computer solve each and every problem we give it? Not necessary, right? Some problems it may solve and some problems it may not be able to solve. Okay, so to identify that, what we can do is we can design a machine for a corresponding problem. So what we can do is we can design a machine for a given problem. So if we are able to design a machine, for the given problem, we call it as computable. And if we are not able to generate a machine, for the problem, what do we have to say? It is not computable by the computer. It cannot be computed. Okay, so since I'm talking about machines, so what type of machines we can design, okay, to identify if the problem is computable or not. So a total of 4 machines. First is your Turing machine. Okay, first is Turing machine. Second is your linear bounded automata. Third is your push down automata, and fourth one is your finite automata. So these are the 4 types of machines. So if you are able to generate any of these machines, what we can say is the problem is computable. If you are not able to generate any of the machines among this, it is not computable. Okay, so let me take a real time example to make you understand what type of problems are computable and not, and and the problems which are not computable. Like for example, if you are given a number, okay, if you are given a number and you are told to check if the number is odd or even. Okay, if you are told to check if the number is odd or even, so is this problem computable? Obviously it is computable. The computer can generate the output for it. But if you are given a program, okay, so if you are given a program and you all are told to check whether the program will stop or run forever. So is it possible for a computer to tell whether the program will stop or run forever? No machine can solve this. Okay, so this was one of the example to tell you all what is executable and what is not executable. So today we understood what is automata theory and why it exists. So if this helped you all, do like and subscribe so more students can find this series. Yeah, thank you.